Good morning, everybody. Thank you for joining us for this Tanzu Office Hours on October 5th. Looks like we've got a couple people joining us. So thank you for spending the time to review the Tanzu Mission Control policy session that we're going to have. Hopefully this is useful for you and this is something that you can take back and actually use in your day-to-day if you're a current Tanzu Mission Control user. And if not, hopefully this is something that piques your interest. And yep, so we'll get started. So my name is Corey Dinkins. I'm a technical marketing architect for Tanzu Mission Control, which in plain speak just means I create technical marketing content that, highlights how to use the product. So again, hopefully things that you can take back and use in your day-to-day jobs. So let's get started with a couple questions. I want to find out a little bit about the audience this morning, just see where you are in your Kubernetes journey, find out if we have any current Tanzu Mission Control users. So let's go ahead and get into some Q&A. First, though, the agenda that we have this morning, I'm trying to keep it pretty light on slideware. So we're just going to do a quick get to know you, going to review some of the different policy types in Tanzu Mission Control and what I guess is supported by Tanzu Mission Control and how you can manage these different policy types. And then I would like to give a brief demo on, the different policies that you can use, how to implement them, and how you can also begin transitioning away from pod security policies because they are going to be deprecated and eventually removed in Kubernetes 1.25. So before we jump into the Q&A, I guess I should probably introduce my panelist here. So real quick, going around the room, I guess let's introduce ourselves. Again, my name is Corey Dinkins, and let's go ahead and hand it over to the other panelists.
Hi, I'm Deshaun Carter, Spring Developer Advocate. Jacked to be here. It's going to be awesome.
As opposed to Jazz did Explore. I'm Morgan Fine. I'm a group product manager on the Tanzu Mission Control product, so also very excited to be here.
And my name is Ryan Conley. I'm a senior staff SC for the Modern Apps Business Unit.
Carol, you go and introduce yourself.
Hello, everybody. I'm Carol. Greetings from Austin, Texas, sunny as Hawaii. And glad to be here. I'm a product marketing manager for Tanzu Mission Control. So looking forward to hearing your questions.
Awesome. And with that, let's go ahead and move on to the quick Q&A. So these are, I guess, all the questions. Let me just take a step back. If I can have the, if the host wouldn't mind helping me throw up the first question. Oh, give me just a second. We'll see if we have this. If not, we'll go ahead and move on and just do the questions. And you can answer via chat, so not really a big deal. No worries. Looks like we're having some poll issues. So the first question that I wanted to go over and just find out of the people that are here now, do we have any current Tanzu Mission Control users or licensees? It can be any of the additions if you wouldn't mind sharing which one it is. There's the Essentials version, which is included with VMC. There's the standard version, and then also the advanced. If you don't know, that's fine. If you could just share if you're actually a user, that would be helpful to know. I'll go ahead and post this in chat as well in case there's people that are multitasking. All right, no worries. Looks like we may not have users or users are not responding.
Looks like it's a crew of new. They're here to learn all the goodness. So that'll make it really easy.
It will indeed. So that's perfectly fine too if you're here just to learn about it, because we're still going to go through, the different policies and things of that sort. So we'll move on to the next question here, which is, how many of you are currently managing Kubernetes clusters, if any? Oh, there we go. Looks like we got the poll working. And if you're not managing them, in production, even, testing or development phases are still fine, because a lot of this is still pertinent. All right. So it looks like most of you in this call are managing clusters, so that's good to see. Let's move to the next question. How many of you are familiar with pod security policies? If you're not familiar at all, that's fine. It's kind of, it's part of the goal here. I don't think I realized that, PSPs were even deprecated until I started this role. So that's something that was, as a former systems admin, that kind of gives me heartburn, because that's a whole, it's kind of like firewall policies. Once you get them in place, you generally don't like to go back and have to check them, remove them, but
I can be vulnerable here. I didn't realize that they were going to be deprecated.
Yep.
Yeah.
So that's good to see.
learning.
So
I'm already learning.
I love it. So pod security policies are currently deprecated, and they're slated for complete removal by version 1.25. So at that point, these were native control mechanisms that were built into Kubernetes. This is one of the early incarnations of their kind of, RBAC or role-based access controls. So it's kind of a legacy implementation, and it just wasn't flexible enough, and it caused far more issues than it seemed to help. So that's what the pod security policies are, and that's essentially why they're going away. So hopefully that helps those users that are not quite familiar with them, kind of give you some background and context. So the next question we have is, is everyone familiar with OPA Gatekeeper, which is the successor to the pod security policies? It's certainly possible you're familiar with one, but not the other. And if you're not familiar with both, I suppose the primary difference between the two is that the OPA Gatekeeper policies, they're a lot more flexible. If you want, there's a lot of things that you can do with it, because you can essentially write your own policies in code. And the name of this language is called Rego, which is spelled R-E-G-O. And this is something that you can do quite a lot of things with. Like, to give you an example, a use case that I've encountered is you can create Rego gatekeeper policies that look at any kind of request for a key from a namespace. And you can essentially control whether or not a key can request a certain key type or key name based on the tags that the namespace has applied to it. So, for example, if we have a namespace that has applied, application A key, the gatekeeper policy would say that that namespace and any pod within it can only retrieve keys that correspond to that particular tag on that namespace. So you can do quite complex things, or you can do quite simple things. It really just depends. So I see nobody's really familiar with OPA Gatekeeper policies, so we'll definitely spend a few minutes going into that. And I guess we'll get to the other question of how many of you knew that PSPs were actually deprecated and have planned to been removed from Kubernetes as a whole. So I think, this is something that's going to catch a lot of people off guard as they start upgrading, and, they deploy the 1.25 template for their dev team or what have you, then all of a sudden everything breaks and they're like, wait a second, like, what did we do? So got it. So a little bit of learning to do there for sure. And then I guess the follow-up to that is, which I can imagine, how many of you actually had a replacement plan for this. For those that were aware, it seems like we only had a few, so. I kind of look at this similar to firewalls, as those age. This is something that it's not fun or easy or cheap, but it's got to be done. Just got to do it. Okay. So for the one user that does have the replacement plan, I'm kind of curious, are you looking towards OPA Gatekeeper as the replacement? Are you looking at alternatives? If you wouldn't mind just answering in chat, that would be helpful. I'm curious where people are trying to go or where they, are at least headed in their journey. Because it seems to be something that's a little bit further ahead than most are ready to handle. All right. So thanks for answering those questions. That's certainly helpful for me to kind of understand like how in depth I need to go with some of these and some of the examples that I need to show. So let's go ahead and move on to the different policy types that are actually supported in Tanzu Mission Control. And what I have in italics under the main policy type is the addition. So I actually forgot to add the essentials on here, but it's going to be similar to what standard offers. So the various policy types that Mission Control supports is access and IAM policies. So you can set up access controls based on existing groups. So you can really align it with your existing security posture or security infrastructure. If you have an existing, Active Directory structure that already, encompasses all the permission structures that you need, it already, has your developers in the correct places, you can really wire this up and continue to utilize that same structure. Next is image registry policies. So those are policies that can be implemented at the organization level and can also be implemented at the namespace level. And the long and short is it just allows you to restrict image pulls from specific registries that you may control or ones that are trusted. So maybe preventing pulls from the Docker registry, for example, is something that can be done. Next, we have network policies, which essentially you can set up. I just would deem it like firewall rules for your pods to keep it simple. Then next we have quota policies, and those are something that you can implement CPU and memory usage quota policies. So restricting how much CPU and memory they consume to eliminate the noisy neighbor issues. If you want to go really advanced, you can actually set up percentage-based quotas. So these are quotas that you would enforce on a certain, percentage or amount of CPU. And if the CPU usage reaches a certain threshold, the policy can automatically allow additional resources to be granted to that pod. So that's things that you can achieve using custom rego policies if you want to get really advanced. Next, which is the thing that a majority of people are interested in, is the security policies. And again, these are all OPA Gatekeeper based and do not use the old pod security policy standard. And then last, we have custom policies, which is, again, it's really whatever you want it to be. So if you can write the rego code for it, you can do it. So pretty cool and pretty flexible. So just a quick comparison of their different policy types that are available in Mission Control and how they're essentially created in the background or what their technology is. So if you look on the left-hand column, you can see that open policy agent policies only encompass security, custom policies, and image policies. The other policies that you see here on the right, these are all implemented using native Kubernetes policies. Not to be confused with pod security policies, just native constructs that are already available in Kubernetes. So things like the cluster role bindings, all those things are utilized for like the access policy, for example. So And then last slide, this is something that we hear quite frequently, and it's a little bit of a misconception that I wanted to address on here as well, and show people how to essentially safely turn off some of their pod security policies, but not be concerned that, like, you know, oh great, I've just turned this off and now my cluster is vulnerable to, you know, images running from wherever. They can run crypto miners, that type of thing. So coming from that perspective, I certainly understand why you'd be hesitant to turn off your native PSPs, but I want to show everyone a way that we can do that safely and actually transition to the newer policy types without, you know, really being too concerned. So if anyone has any questions, I'd like to take a quick moment to pause and see if there are any. And if not, we'll go ahead and move on to looking at some actual mission control usage and demonstrations. And actually, let me get some water as well. All right, doesn't look like we have any questions, so we'll go ahead and move on. And I guess we can take a moment and look at the, Ryan put a link in the chat here, which is the Open Policy Agent. So this is a CNCF graduated project. And the long and short is, you know, the pod security policies just weren't working as well as organizations wanted or needed. So this was a way to offer a much more flexible policy, I guess, language, and yeah, I guess give companies a much better way of enforcing the type of controls that they wanted to. So it was a little bit of a struggle with pod security policies. And I did have a link for a website that I wanted to share that actually, so if you're currently managing pod security policies, this website can actually take those and translate them into a corresponding OPA Gatekeeper policy that makes life like really simple. So you don't have to sit there and hand translate things. So, and I guess one of the other important things to note about the Open Policy Agent and Gatekeeper is that, and I don't have a graphic for this. I wish I would have put this in my slide deck, but the way OPA Gatekeeper works is it's an admission controller. So if you're going to go through and start enabling security policies and restrictions on namespaces and pods, the one thing you need to be aware of is that any currently running or existing pods won't get killed or pruned out as part of turning on your OPA Gatekeeper policy. And the reason that's the case is Gatekeeper really checks on admission or request of a resource. So user says, I want a pod that has these properties. OPA Gatekeeper checks against its rule lists and says, you know, yes, this is allowed, or no, this is not. So any existing pods and stuff that are running, you'll need to kill or repave to make sure that they're actually, the policies are actually getting applied that you are expecting. So that's something certainly to be aware of. So moving on, I wanted to address the last point in my slide where, you know, again, I was saying, you know, we have a lot of customers that think, so your instructions tell us we need to turn off pod security policies just to run these Tanzu packages that you have, but you're making our cluster vulnerable if we do that. So let's go through and look at an example policy and see how we can still allow certain things to run and disable this pod security policy without having concern that we're exposing ourselves. So as you can see here, I've got a few clusters that are running on vSphere. I'm going to go ahead and go to the policy section. And as you can see, I've got a bunch of different cluster groups that I've set up in here for various purposes. In this case, we're going to look at the hands-on lab cluster group that I built. And this is one that we utilize for our marketing team. So we all share this mission control environment, and it's something that I help manage them. So looking at the current security policies that we have applied, you can see I've got this baseline template. And if we look at what the template is actually doing, you can see that it has a few, I guess, what we call basic or baseline security restrictions on it, where we don't allow running of privilege containers, but we do allow privilege escalation. We don't enforce the run as non-root rule. Boy, that's a mouthful. We're currently left it as run as any, which in some environments that's, not allowed. And a couple of other different basic restrictions that we have. And moving further on down, I guess the part that I wanted to highlight is this section where we can utilize label selectors to actually target namespaces. So again, we have situations where we're trying to deploy application X to a namespace, and in our case, some of the Tanzu packages require this. So I guess going back to the different label selectors, some of the Tanzu packages require this, and in this case, there's an app that we have that's a source controller. And what this policy is doing is we're only going to include specific namespaces to actually exclude. This is kind of a little bit backwards, so let me make sure I explain this correctly. So for this example, we're only going to target specific namespaces to disable the native pod security policies. So that's what the end result of this policy is meant to be. And in our case, the only namespaces we want to disable our pod security policies on is namespaces labeled with app equals source controller. So we've added that selector, and I've instructed Mission Control to disable the native pod security policies because we're going to supersede them with OPA Gatekeeper policies and essentially still leave our cluster protected, but we know that this namespace is running securely. So we can click save, and we can know that our pod security policies are still enabled on all the other namespaces except for the one that has the source controller tag. So this is a way that you can actually control your policy application to namespaces and actually start doing a phased approach to moving away from pod security policies if you actually have them implemented. So that's something that I think is pretty powerful, and it's a little bit confusing, I guess, as to how this works and the fact that you're disabling the native pod security policies, but I don't know of a better way we can handle like transitioning between them. I kind of look at it as transitioning between firewall rules and ordering. So there's the baseline security policies and how you can actually target different namespaces and kind of leave native pod security policies enabled and also utilize the newer policies if you'd like to. So looking at some of the other policy types that we have image registry policies, which can be applied at the entire organization level, or they can also be applied at individual namespace levels, or even individual workspace levels. And a pretty common one that we see is the ability to block the latest image tag. And this is something that has caused a lot of issues in different environments due to pulling down, a newer version of an image, the image maintainer making changes to security settings or things of that sort. And now your entire application breaks. So we actually include a default policy template that's called block latest tag. And again, you can go in here and you can actually set the different scoping of this policy to different namespaces. So if you have a development namespace, for example, that you would like to continue allowing to pull the latest tag because they're testing it or running end-to-end pipelines or things of that sort, you can continue to allow certain namespaces to, again, circumvent this this latest tag if you'd like to. But if not, again, you can just leave it as is. And let me actually. So I actually forgot which cluster I put this on.
But we've all been there, right? This is one of those things that tripped up a lot of people for years, because you don't know when something got the latest tag, when something got the new version. So you could, at scale, you could have a system unknowingly have two different versions of the same image running.
Right.
And that's caused more headaches for more people. This should be enabled by default, applied across the board. Don't get burned by that one.
Yep. Yeah, so ideally you'd want to set it at the org level and make sure that just isn't a problem. It's kind of like DNS, right? What was the problem? Oh, it was DNS again. Dang.
Couldn't be DNS.
Couldn't be DNS.
It wasn't the latest tag.
So that very useful to have. And again, the other effect that this has, you can also create image policies that allow you to restrict image pool access to specific repositories. So if you've got a repository that you host all your custom builds and it's secured, you can make sure that that's the only place that people can pull images for any cluster that's managed by Mission Control. So I think that's quite useful. So moving on to some of the network policies that we have available. There's a couple of different templates that we have built in. And I think, I actually believe I added some of these myself, because we can't currently do deny all egress. Unless that's changed. Sneha, do you know?
Sorry, what was the question?
We still cannot do a deny all egress for pods, correct?
Yeah, I believe we are in the process of making some of those changes, and they should be out soon.
Okay.
Yeah.
So in my case, generally, I guess I would consider myself a power user. I generally do things more manual. So in my case, I would generally be choosing like a custom ingress policy and choosing the different IP ranges that I would be allowing to access these pods. So if you're trying to limit access to pods based on source networks, you can do that. You can also do it by selector. So if you have apps that are spanning multiple namespaces, this will make it a little bit easier than trying to remember namespace to address space associations. So certainly makes it a lot easier to kind of mix and match your policies that way. And I guess one thing to note as well about the network policies, and this is one of the details that I only learned recently, is that we don't show violations for access policies, or I'm sorry, network policies in our policy insights because of how Kubernetes is built, and essentially those violations are not really counted against the admission controller, so we can't really alert on them per se. So something to be aware of. And then quota policies is something that, depending on your org, these may or may not be important. For orgs that have a lot of teams and that have resource constraints, they use this quite frequently. One of our customers has over, I think, 400 different quota policies because they're applied to every namespace that they have created. So they like to keep things really tight and make sure that they don't have noisy neighbor issues that cause issues over in the production side. So these quota policies can be applied to the organization level. They can also be applied to different cluster groups. So if you have development cluster groups that you want to, not really have too many quotas on, you can do that. But you can really mix and match these, just like the other policies, to really fit the needs for your organization. We have some pre-selected template types that you can choose in here, and I think most people will probably go into custom and kind of build out the different requests that they need to make sure that they don't hit limits they weren't expecting. So you can put limits on all the different objects within the pods, just like you would be able to natively in Kubernetes. So quite useful if you have a resource constrained environment. And then last but not least, we also have the custom policies, which are policies that you can hand create using the Rego code. I guess I'll put this in the chat as well. Where's the playground?
I can find it.
All right. If you wouldn't mind finding that. So there's a place in that the Open Policy Agent website offers you that essentially allows you to create policies and test them against enforcement and see what you get. Thank you. So if we look at some of the different custom policies that we've got here, I actually created some of these myself. Let's take a look at the template view. So one example is you can actually instruct a gatekeeper to disallow certain tag types. There's a lot of stuff in here and it looks kind of crazy, but I think, let me find the actual violation for you. Yeah, so in this case, this policy is a custom one that requires a specific image tag. So if you've not included one, generally that defaults to the latest, which is something that's not desired. So this is a rule that can be used to enforce requiring labels and additionally disallowing the latest tag from being used. So quite powerful because this Rego code is essentially like a coding language that is translated into policy. So quite powerful. And I think one policy type that I actually glossed over, which is quite important for a lot of people, is the access policies. So again, these are policies that can be tied back to your existing authentication infrastructure. So if you already utilize Azure Active Directory, Okta, you can connect those different IDPs to Tanzu Mission Control, and you can actually start utilizing existing groups and existing authentication infrastructures to start carving up access to your different clusters. So as you can see here, some examples that we have and how we've structured this organization is we've got the platform ops team. They're full cluster groups admins, which means any cluster groups within this org, they can essentially do what they need to with. We also have this other team that we've manually assigned to this role. And it's a group because you can tell these this 3-person symbol. But we can go down and assign these different access policies further down in the structure. And anything that you assign to groups supersedes what you've assigned at the organization level. So you can have things structured in such a way to where your ops team, has access to all your clusters, but certain developers may only have access to clusters that's residing in the dev group. So I'm going to go ahead and create a role binding for this dev group. And in this case, only want to give cluster view access. So this user, I only want them to be able to get in and essentially take a look at this cluster and not really be able to do a whole lot. So Ryan's always messing up my environment, so we'll use his as an example. So we've added Ryan. He's got view access to this dev group, and we'll click save. And it's really quite simple to get everyone added in. It's just a matter of actually matching this up to your current infrastructure and I guess verifying people have the correct roles and permissions that they need. Oh, we don't
And
have
the
any
cool power
clusters.
of that workflow is we're taking your identity provider, like Azure Active Directory, for example. So you have your source of truth, so the identity of the users, and then you're applying both the access as well as the authorization. So what can they actually do? And that is being applied at the Kubernetes level for Kubernetes RBAC.
Yeah, and all these roles, thanks Ryan. And these roles essentially all translate into, again, cluster role bindings within the Kubernetes cluster. So it's not an additional, authentication type, or, it's not yet another layer of things that you have to learn. This all just is implemented as native Kubernetes RBAC. And from that perspective, it makes things a little bit easier to troubleshoot. And again, you can override this at the group level and even at the single cluster level. So if you're really trying to restrict things, that's something that can be done. Do we have any questions up until now? Any questions on OPA or policies that maybe you would like to see or implement in your own environment? If not, no worries. We'll go ahead and take a quick look at using the latest tag image policy and looking at what it actually looks like when it's enforced. So let's make sure, first off, I've got the policy applied. Looks like I do. Let me actually log into the right cluster. I believe this is the right one. And for those watching, I use K as a substitute for kubectl. So no BusyBox pods running. So I'm going to create a pod real quick. Well, if it'll create. Well, while that one creates, let me make sure. Nope. Oh. This is what I was saying about Avi. I should probably shouldn't mess with it prior to. Well, let me try and create that again. There we go. So we've got the latest tag here. Oh. Boy, terrible demo. I forgot to change my image repository to the correct one. Do you remember the Harbor proxy address, Ryan?
I do not off the top. Let me
Oh
see.
boy. One of these here. Here we go. Sorry about that. I thought I had this one ready. So let me just put this in the right repo real quick so we can actually pull the image. There we go. So that's our latest one. Let me update this. All right. So let me go back into my cluster here. Make sure BusyBox is running. Nope, not yet. Oh, there it is. I need the full name. No. Well, what I'm trying to show right now is I want to get this BusyBox running and I want to turn on this image tag policy. Then I can actually show you what happens when we try and we kill the pod and it tries to actually rerun. Goodness. So if we look at our pod, we've got the tag here. As we can see, it's running. Where is it here? So we've got the successful image pull and it's got the latest tag, as you can see. So what I'll do is we're going to go back into the policy assignments and we're going to set up an image registry block tag for latest. And in this case, we're going to set it up for the entire org because we don't want these types running in production. So we're going to create the policy. And again, this is going to encompass any workspaces that we have applied within this organization. So let's go ahead and delete the pod. And again, we have to delete the pod to try and recreate it to ensure that the admission controller actually picks up the request and is able to deny it. But it seems my cluster is taking its time. There we go. So that's gone. Let's try and create that. Nope. Did I not apply that correctly? Apparently I forgot how to use my Kubernetes control. Oh, that's still running. Did I not apply that correctly? Man. Where's my busy box? Well, that didn't go terribly well.
It's okay.
One
It's okay.
classic demo.
Yeah.
No worries. Yeah, so let's try that again real quick. Let me just make sure I've got all the right stuff here.
I'll say that oftentimes I learn more when the demo goes wrong by watching how people try to debug the issue that they had in their demo.
You are not wrong. It's always a learning experience.
Yeah, I've learned to embrace the busted demo for that reason.
Yeah, I think I know why. So I guess one of the things that I forgot to cover is the fact that in order to apply our policies to a namespace, we actually have to manage it as well. So let me go ahead and put this in the correct group. And I usually do this beforehand, but when you do something so many times, you kind of forget some of the finer details. So apologies for that. Let's just go back in and make sure that we actually have that applied now. There we go. So because I've actually got this defined at the organization level and at the group level, what we're seeing is it looks duplicated, but this is actually working as intended. So let me try and delete that pod again. And we'll actually make sure this rule works because I know this functionality works correctly. I've done it many times. Also, this is why you don't mess with your networking before you start a demo. Because I've done something to my lab environment and I'm not exactly sure what. All right, so no busy box. So this is what you should see if you're actually trying to create something that is against any policy. So ignoring all the kind of, gobbledygook here that we have, the key message is, I'm using an invalid image reference, which is essentially saying I cannot be using the BusyBox latest tag, or rather the latest tag. So denies the request and we don't get to create pods. And that should be the expected behavior of it. So if you actually manage your namespace correctly, that's what you'd get. If there's any questions on that, feel free to put them in chat. Sorry for fumbling through that for a couple of minutes, but we finally got there.
I don't see any
These are
questions,
just-
but I think it's worth kind of expanding that. We just set up a specific policy and it was custom that met the needs of our path to production. But there are a number of others. So for example, the power of OPA and just Kubernetes in general is you might have people who are learning Kubernetes, and as a systems admin, we are very familiar with single points of failure, but maybe they aren't as familiar. So you could have one that I've seen customers deploy is just a minimum replica set. So when I do an application deployment on Kubernetes, the minimum for production needs to be at least 2 which sounds trivial and kind of funny if you think about it, but that's just as someone learning Kubernetes. As well as you see the image registry. Maybe you have your intellectual property, an Artifactory or something on-prem, or maybe you just want to prevent random images from Docker Hub, just because you don't know what's in them, whether it be a CV that's been hiding for a year or a crypto miner, et cetera. This is a very easy way to secure your path to production.
Great points, Ryan. And that certainly is the goal behind Tanzu Mission Control, is to help aid with that process and again give you the reassurance that things are being enforced consistently and across all of the different properties that you've put under its control. So a lot of peace of mind there. And as a former systems admin, knowing stuff like this is enforced without having to go back and do run CIS checks and all these other type of things. Not to say you shouldn't do those, but instead of having to do it so frequently, you can kind of relax that a little bit and, use this and know that it has things taken care of. So certainly one of the benefits, and I think one of the big points for using Mission Control as a whole. So I think with that, I guess we can see if there's any questions and we can, wrap up the presentation. Any other panelists want to add anything?
I like to say at dinner, if you leave and you're hungry, that's your fault. So when we have office hours, if you've got questions, you've got to ask them. If you leave and you didn't ask your questions, these are the experts right here. If you didn't ask your questions, that's on you. But you can always bring them back next time.
You can.
That's all I wanted to say.
Because we have our next office hours on, oh boy, was it November?
December. I believe it's December 13th.
December 13th. So Ryan Conley is going to be the presenter for that. Ryan, do you want to give a brief overview of the topics?
Yeah, we kind of want to expand on the topic of security as well as some other customer challenges around upgrades. And so the idea is we're going to leverage the last two sessions and build off. And so in this case, we're going to focus on, there's a very common methodology that I know Deshaun is familiar with, which is the 5 Rs. But in this case, we're going to look at the 5 Rs is paying attention to the applications, and we're actually going to look at the platforms that are supporting those applications. So how can you do long-term strategies for retiring old Kubernetes clusters or rehosting existing platforms that need to stick around to support applications that are going to be around, as well as moving forward.
Awesome. Looking forward to it. Thank you so much, everybody. Thank you, panelists, and everyone have a good afternoon or good night.